All right, so we want to look at the difference between trig ratios. Trig ratios and pi. This thing. Pi. Pythagorean theorem. I hope I spell this right. Now, we want to look at the difference between these two because sometimes you have students who are mixing up the concept when to use these idea or method to solve sides or even angles on the right triangle. We're going to look at the difference between the two. Very, very simple. Now, if we try to review on the concept of Pythagorean theorem, we have this formula: a squared plus b squared is equal to c squared. Now, if you look at this carefully, if I have a triangle like this, a right triangle, and I want to find this, we have this B, A, B, C, and we want to find, let's say we want to find one of these sides. If you look carefully, you can see that we have sides on this triangle that are missing. In this formula, which is the Pythagorean theorem, we have only sides in this equation. Therefore, this equation would be appropriate or suitable to solve any missing side on this triangle. And so we use this theorem to solve for right or solve for sides, only sides on a right triangle. Well, let's review what the trig ratio looks like. Now, the trig ratio is like simply you have ratios as you have three basic functions. Let's use cosine, tan. And for each of these functions, it has the theta that is assigned before them. And if I were to draw a triangle like this, this triangle has a reference angle right there. Now, if you remember Pythagorean theorem, Pythagoras theorem doesn't have anything in its equation to accommodate angles. So if I wanted to find a missing side here, well, let's have x is right there, and let's say this is like 5 meters, or let's say I change this angle to like 36. Well, the thing is if I wanted to find the value of the missing side, which is the hypotenuse, could I use the Pythagorean theorem to solve this? No, because this theorem has nothing in it to solve for. It has nothing in it to accommodate this 36 degrees. And so we could not use the Pythagorean theorem to solve for missing sides or missing angles in a right triangle that has a reference angle in it. We could not use that. So we have to use one of these. Because if you look, you're seeing the theta right here, like you see the theta right here. So we must understand which is the more appropriate theorem to use. So the Pythagorean theorem strictly solves only missing sides of a right triangle that does not have any reference angle in it. This doesn't have any theta in it. We call this theta, which is like a Greek word that talks about angular measuring something, right? So, and if you look at the trig ratio, the trig ratio is only used when you have a reference angle in it. And if we were to review the trig rule again, the trig functions again, we have cos theta. We have. I'm not even going to put the sides there. Just the basic idea of this. So these are used. You use these to solve problems when you have a triangle that has a reference angle in it. Let's see if we'll go further in this concept. Now, let's say I have this triangle right here, and I want to find the value. Let's say I label this as 6, I label this as 8, and I want to find this part. Now, if you look at this carefully, if I were to use any one of the trig ratios function. Like, let's say if I want to use sine, or I want to use cos, or I want to use tan. Now, if I were to use any one of these would not be even appropriate. Let's try to see all the sides that are associated with each function. If you remember Sokotowa, that is something that you could use to remind you of which side is associated with which function. Now, if you look at it carefully, remember that this all represents opposite side. Now here, we don't even have an opposite side here. Now this side represents what? The adjacent side. We don't even have any adjacent side here. This side is, the only side we have is hypotenuse, because the hypotenuse is a side that is always there, whether or not you have a reference angle inside. So the thing is, if we were to use the trig ratio from functions to solve for x, this wouldn't make any sense, because in order for us to choose any one of these, we must have an angle in the triangle. We don't have any. We must have either an opposite side or adjacent side. This hypotenuse side is always there. But guess what? We don't have any opposite side. We don't even have any adjacent side. Because why? In order for us to have an adjacent side or an opposite side, we must have a reference angle. And we don't have that. Therefore, this problem that we have right here can only be solved by using the Pythagorean theorem. And so if you look, you have A, B, and you have C. And you plug the values in. A squared plus B squared is equal to C squared, and we boom, try to find the longest side. Let's try to look at something else. If I had this triangle like this, and I say, let's say this side is 12, this is 60 degrees, and this is x. And I say, I want to find the value of x. Let's try to see if the Pythagorean theorem would make sense. If I use the Pythagorean theorem to solve this problem, let's see all the information that we have in this triangle, so we could substitute them into the formula. Now, number one, we want to find this side. Now, if we were going to use the Pythagorean theorem, remember that the two short sides could be substituted into any one of these. So if I were to plug x in any one of these short sides on this side of the triangle, I put x right there. Let's just try it randomly, put x in one of them. X and put a square. Now, if I'm going to say, okay, let's use this as a longer side, no problem, because this is over the hypotenuse. The C always represents hypotenuse. So if I say, okay, I'm going to put 12 there, put 12 there. Now, B is the only thing that is missing. What is it that we can put for B? We have nothing more to put for B. So this in itself makes no sense. No sense. We could not take 60 degrees, and put it there, because this is this should be only assigned to a trig function that when you plug that into the calculator, it gives you a value or a figure. Now, so the Pythagorean theorem could not be used to solve for a missing side nor an angle when you have a right angle triangle that has a reference angle in it. So what's the difference between the two? The Pythagorean theorem is only used to solve for right angle triangles that has no reference angle. But the trig ratio is used to solve, the trig ratio is used, which is sine theta, cos theta, sine theta. And if you want to put the associate sides that they share, that they normally work with, you could put it there. Now, these functions are used to solve triangles that have what we call a reference angle in it. So that's just the difference between the two. I hope you got some clarification on this. and we know what to do next time. Please remember to subscribe and like and share my video. Stay tuned for more videos.